Hello and welcome to another ScienceMan digital lesson. Today we're going to talk about generators. Now here's a really large generator that you would find in a typical power plant. These are really crucial to our society as generators produce electricity which runs our homes and businesses. But exactly how do these generators work? Well, let's take a close look by looking at a simulation of a generator, and what I have set up here is a very simple generator with a lamp attached to it, and there's a current indicator. Right now the generator is not spinning, so we have a current of 0. We have a hand crank. This is just a way of turning our generator. In the middle of the generator, we have probably the most crucial part, the piece of wire that moves in the magnetic field. That's the armature of the generator. And we also have another necessary component of the generator, and that's the magnetic field. And here we have the North Pole and the South Pole, which creates our magnetic field, and it's oriented in a north-south direction. You can see it by the lines with arrows on it. So once we get this started, and in a minute we'll just auto-rotate this handle and see what happens with our current generation, we'll be able to see how this generator creates current. So let's go ahead and do that, and we'll start this up and allow it to turn. So as this generator begins to turn, you'll see a couple of interesting things. One is that our current is fluctuating, and we're definitely getting some current out of this generator. It seems to be changing from positive to negative though, and going from high to low numbers. So it's going all the way up to in the mid 400 milliamps down to negative 400 milliamps, and everything in between, including 0 milliamps. So we can, if we also look closer, and we'll just speed this generator up even more, increase the rotational rate. So now it's spinning quite fast, and you can actually see the light pulsing. So we're getting light out of the lamp. Now we're not getting steady light, we're getting pulses of light, and that's another indicator that the current's not staying steady. It's fluctuating. And that makes sense because what we actually have here, if we look closely, we have two commutators. What we have is an alternating current generator. So the current fluctuates back and forth, and it doesn't move directly. Now, why is it that the current is actually getting generated? For that, what we really need to do is slow down our generator and take a closer look at what's happening when the armature in the middle spins in the magnetic field. And what we see is that the creation of the current seems to be tied to the position of the armature. And as the armature swings through the magnetic field perpendicularly, we get the most amount of current being generated. Another thing that's quite obvious is with a slower spin of our armature, we get lower current amounts. So that's one thing that we've learned for certain. The faster you move a wire in a magnetic field, the more current you generate. Now let's take a close look at the positions of this armature. We're just going to pause it right there, and we see we have pretty much a maximum current value, and that's at this position when the armature, the loops of the armature, are moving perpendicularly through the magnetic field. Now let's just rotate this armature about 45 degrees, and we see that our current has dropped nearly to nothing. And that's because in this position, the armature is now moving parallel to the magnetic field. So that's another thing we've learned about generators, is that when you move a wire parallel to a magnetic field, you don't get any current induced. So you have to move the wire perpendicularly to the magnetic field, pushing it through the magnetic field perpendicularly in order to get current generated. So let's again just start this back up again, and we'll once again speed it up just to confirm. Right now we're at about 200 milliamps, but we'll speed it up a bit just to absolutely confirm the other thing we learned. And indeed, there we are with a fast turning generator moving the wire fast through the magnetic field. We now get very, very high current values. So that's the basics of inducing a current. And the other thing we've learned is that this current alternates. So if we were to graph that current, we'd see a line that forms kind of a sine wave where our current goes up to a maximum and then down through zero and then to negative values and then back to zero, and it repeats. And that's different from direct current, which just stays at a very steady value. So thank you very much for viewing this digital lesson. Just a reminder, I've done this simulation with the help of a program called Yenka. If you haven't tried it out yourself, it's great for science simulations. Go to yenka.com, download it, and give it a try. Thanks very much.